Assalamualaikum warahmatullahi wabarakatuh to Dr. Aina. My name is Wan Adrina Izzati binti Wan Matai. My matrix number is S58336. Today, I would like to present about problem 8.1. For the first question is formulate as an LP problem. The data of net revenue of cabinet show S1 is 28 and S2 is 25. So, we proceed to formulate this linear programming problem as follows. We will maximize revenue equal to 28x1 plus 25x2. The subject to this constraint, and we see carpentry hours for x1 is 3 and x2 is 2, and department capacity in hours is 360. So I conclude the constraint is 3x1 plus 2x2 less than or equal to 360. Secondly, spending hours for the x1 is 1.5 and x2 is 1, and department of capacity in hours is 200 hours. The constraint that I can put is 1.5x1 plus 1x2 less than or equal 200. Lastly, the finishing hours for x1 is 0.75, x2 is 0.75, and department capacity in hours is 125 hours. Here, I can conclude that the constraint is 0.75x1 plus 0.75x2 less than or equal 125. The firm has a contract with an Indian distributor to produce a minimum of 300 of each cabinet per week or 60 cabinet per day. The X1 and X2 should have non-negativity constraint, and I conclude that X1 and X2 greater than 0. It is equal to 60 cabinets per day. As we can see, we have two variables to maximize the profit or revenue. So we start by defining the decision variables. That is S1 refer to French provincial and S2 refer to Danish modern. So we have a solution here, and we have the net revenue of a cabinet, and I put here the total net revenue. So we continue for the solution. So I put the value of 1 for x1 and value of 1 for x2. And the net revenue for the x1 is 28 and the net revenue of x2 is 25. So we use for the function for the total revenue is equal sum product bracket, and we highlight the first line of solution value, and we put a comma, and we highlight the second line of the net revenue of a cabinet, and we put a bracket, and we enter. We continue for the constraint that we have a constraint 1, carpentry department, painting department, finishing department, contract of French provincial, and contract of Danish modern. So over here we put the LHS that stands for the left hand side, and we put the RHS stand for the right hand side, and among the two sides we put the symbol of less than or equal for this three constraint, and we have a great symbol of greater than or equal for this constraint, these two constraints. So we continue. For the first constraint is a carpentry department. For variables x1 is 3 and x2 is 2. The first subject we put is 3x1 plus 2x2 less than or equal 360. So we put 360 at the right hand side. And secondly, for painting department, constraint is 1.5 for x1 and 1 for x2. And this constraint shows that the less than or equal to 200. So we put 200 at right hand side. The third constraint shows that x1 is 0.75 for x1, and we put the 0.75 for x2. And this constraint is less than or equal to 100 125. So we put 125 at the right hand side. The fourth constraint is x1 is 1 is a greater than or equal to 60. So we put 60 over here at the right hand side. And the last constraint, the fourth constraint, is x2 refer to 1. This constraint shows that greater than or equal 60. So we put 60 here at the right hand side. And now we focus on left hand side. The left hand side value is the calculation of 3x1 plus 2x2. So we calculate as like this, equal sum product bracket, and we click the first line of solution, that is D27 until E27. We put a comma and we take the first constraint, the value of first constraint, D32 until E32. We bracket and we enter, and we continue the first step with same step like first. So we highlight there and we take this and bracket, also this one. So we have a complete our table right now. So now we focus on solving to maximize the revenue. First we go to data and we pick a solver and we set the objective. Set objective or the total net revenue. We take this one F28 and we click max because we want to, because I would like to maximize the revenue. Secondly, we go to the by changing variable cells and I take the D2, D27 until E27. So I go to the subject to constraint, I choose add and I look at the similar sign of the value of the three constraint. So I take the LHS value, this three constraint LHS value, and this I take the less than or equal, and the constraint I take the value of the right hand side. So I click OK. After that I add another sign for the constraint 4 and 5. I take the LHS part for the value for the constraint 4 and 5, and I choose to greater than or equal, and the constraint I take the right hand side value and I click OK. To get the positive answer we click here, because we want to make a non-negative, then we click solve. After that it come out like that, and we click keep solver solution and then we click OK. So this is the final answer for the problem 8.1. That's all from me and thank you. Assalamualaikum warahmatullahi wabarakatuh.